All right. Okay. Thank you very much to our chairperson today for our conference, Chemistry Frontier. Today I'm Mohd Akmali Mokhter from Universiti Teknologi Malaysia, Department of Chemistry, Faculty of Science, Malaysia. Okay. I'm presenting our research group latest finding on our research on wastewater or water reclamation, basically. So our topic today is on the novel cellulose electrospun membrane for phosphate adsorption and potential recycle fertilizer. So here is all the names from my research group members, including my students who are actually working on this project. And this project is actually funded by our Malaysia Fundamental Research Grant Scheme, FRGS, for 2 years of study. Okay. So I will start with some research background. So basically, as we know that excessive discharge of phosphate in agricultural and industrial areas can cause possible land and water contamination. Okay, in agricultural sector, fertilizer, particularly organophosphate. When we talk about phosphate, it is certainly related to the agricultural sector. Okay, so this kind of species or animal waste are remain factors that may cause the pollutants to the water course. Okay, wastewater from industrial sector like steel and chemical industry contain high amount of contaminants, especially heavy metals, and this can lead to severe water pollution. And the problem is when there is an improper and ineffective wastewater treatment will also contribute to this kind of problem. For your information, excessive phosphorus in water bodies can increase the growth of algae and aquatic plant in a pond that leads to the eutrophication problems. And this phenomena can harm our river water quality, river or lake water quality system, aquatic life. And Malaysia, our government has set a limit of 5 milligram per liter phosphorus in an aquatic life for the enclosed water body, and only 10 milligram per liter of phosphorus released to the rivers as an acceptable condition for effluent. So in order to treat the phosphates that can lead to the eutrophication, the excessive amount of phosphate, we have come up with a lot of technologies in order to treat our polluted water. For example, we are using the technology like membrane filtration. We use the method like biological methods or chemical precipitation, and including the separation using membrane or adsorption. So the adsorption process is one of the favorable method to decrease the level of phosphate ion in water. Okay, because why? This method it can be considered as low cost, simple for the operation, and also have a good efficiency. We have a lot of adsorbent that have been utilized for phosphate removal based on the literature review, but it is still important to develop an alternative way to develop a new low-cost adsorbent. Okay, for example, in our case, we are using cellulose acetate. Besides that, the polymeric membranes that can be produced as an adsorbent. Okay, we can also develop a new one and enhance their performance by modification using other kind of materials like graphene oxide, because we know that graphene oxide have a good capacity and ability in order to reduce the problem of membrane fouling. Okay, so this is one of the strategy in order to enhance the performance of our materials. For example, in this case, it is actually the membrane, but we use it as an adsorbent. So the problem statement is actually the phosphate that presents in the streams of water, okay, that we need to overcome, or how to treat them in a proper way, especially without doing or creating the secondary pollution. The chemical precipitation and biological treatment have some drawbacks. Okay, So adsorption is one of the favorable and easier way to treat this kind of problems. And in this case, in our study, nanofibrous membranes can be a potential and effective way for the surface adsorption of phosphates. Okay? And as we know, as from our part of study, we have studied this kind of problem using different kind of membrane. For example, flat sheet polyethylene sulfone. It is not really capable to remove this kind of biological products from wastewater. So we try to come up with the new idea in order to create the novel membrane to tackle this issue. So the objective of this study is actually to fabricate the new electrospun cellulose acetate, and basically we want to develop the new one that has been modified with graphene oxide and sodium dodophyl sulfate, which is the nanofiber membrane using the electrospinning method in order to remove phosphate ions. So once the membrane is fabricated, we will study the morphology and all the characterization on the novel membranes fabricated, okay, using different types of microscopy and spectroscopy methods. And then we want to evaluate the ability of the resulting electrospun nanofiber membrane that has been produced or fabricated in phosphate ion removal by adsorption process. Okay, and then we want to try in order to not create the secondary pollution, since some of the membranes that have been used cannot be recovered. So we come up with an idea that the membrane that we will use to remove phosphate ions from wastewater, since it's containing phosphate, okay, so we want to try to reuse the used membrane containing phosphate ions as a new fertilizer for the plants. So that is our future prospect or plan in order to create and use this membrane to absorb the phosphate and then can be reused again as a novel as a potential fertilizer. So the scope of the study is to prepare the membrane itself from the solution, cellulose acetate, graphene oxide, and sodium dodopyl sulfate. And then we have to electrospin the membrane using the parameters that has been set. And then some of the membrane need to undergo the coating process to modify. And then we do the characterization using several techniques of characterization like ATR, FTIR, SRD, FISEM, image, and then contact angle. And then the evaluation at the end is to test the capacity of this novel membrane as a good adsorbent in order to absorb the phosphate ions. And we want to study about the adsorption studies, okay, based on the pH, the immersion time, mass of membrane, and then later we want to calculate using the mathematical methods, kinetic study and adsorption isotherm using Longmuir or Freundlich models. And then at the end, we try to apply our real application of the used membrane as a fertilizer. And the significance of this study is actually, we know that this kind of study has a great application, which is very clear. We want to treat or tackle the issue that is very serious worldwide. Okay, so the application is very clear. So we are clear with our objective of the study and the awareness to all the people in this world about the environmental issue and the pollution problems around the world. So we are actually focusing this study based on the United Nations Sustainable Development Goals, okay, based on the 17 goals that has been highlighted under UN SDG. Okay, we have some of the points that are very related to this study. For example, the clean water and sanitation, good health and well-being, climate action, life on land, etc. So we are actually focusing our study in line with what has been highlighted by this SDG United Nations. And then the last one is the significance of this study is one where we can apply or reuse the fabricated membrane and has been used for absorbing the phosphate as a potential fertilizer. So the literature review why we focus on these materials, for example, and the methods that we used, because the electrospinning process is actually one of the method that is not really uh, uh, discovered by or used by many group of researchers in order to produce the membrane, while actually fabricating the membranes using electrospinning process will give you benefit in order to get the very fibrous shape of the membrane that will be very what we call not only fibrous but will also be what can I say? I don't get the name or the word. Will increase the porosity of the membrane. Okay, and then cellulose acetate, since it has a good characteristic of hydrophilicity, excellent adsorption capacity, and also mechanical properties. Okay, and the graphene oxide that we choose here is because it is able to enhance the mechanical properties, improve the anti-fouling properties. And why we add SDS in this material of a membrane is because of the amphithetic and ionic surfactant that can form the micelles for solubilization and can solve the agglomeration issue for graphene oxide. So it is like the additive to enhance the performance of the fabrication of the membrane. So the methodology is by preparing the solution. We prepare the solution, 13% of cellulose acetate, okay, dissolved in the ratio of binary solvents, 2:1 acetone to GMAP, and also 30% GO and SDS. And actually, we prepared also CaGO SDS 13% altogether using the same binary solvent ratio. And then once the solution has been prepared, we electrospin the solution that has been produced, that has been mixed well, using these parameters that has been set constantly for all the spinning process. 20 kilovolt, 50 centimeter, the distance between the needles of the string and the receptor plate at the 20 milliliter per hour of the rate. Okay, and then some of the membranes need to undergo the modification if necessary, and then the characterization, and then the absorption process is actually by emerging the membranes based on the size and weight of the membrane needed in the solution, aqueous solution of phosphate. And the immersion time will be the parameters, the mass of membrane, and we also studied about the kinetic and absorption isotherm study in order to study the performance of the membrane as a good adsorbent to remove phosphate ions. And then the characterization using FISM EDX before and after adsorption process, and also determination of the concentration of phosphate ion in the water before and after adsorption process using color wave spectrometer. So the results will be shown in this next slides. Okay, so this is the results from the preparation of the solutions, because the preparation of the solutions using the binary solvents is not really easy as we think, because we have to test with different ratio, different percentage of ingredients in order to get a very good condition of solution in terms of viscosity and the transparentness of the solution. Okay, because the viscosity of the solution obtained will determine the quality of the electrospun membrane that will be produced by the